In this video, we will be going over carboxylic acids. We will first look at the curved arrow mechanism under basic conditions. The first step is to have the OH group do a nucleophilic attack. The second step is to have the loss of leaving group, as shown by the curved arrows. The third step is to have a proton transfer. Next, we will look at the curved arrow mechanism for the hydrolyzation of an ester under acidic conditions. The first step is a proton transfer. The second step is the nucleophilic attack of water, which will break the double bond. Next is another proton transfer. Then there's another proton transfer. Then there is the loss of a leaving group. And finally, the last proton transfer. The first proton transfer makes the carbonyl carbon more electrophilic. The second proton transfer neutralizes the oxonium, so it's not a good leaving group. The third proton transfer makes a better leaving group. And the fourth proton transfer neutralizes the oxonium, so it is more stable. These are three different ways that esters can be made. The first is an SN2 reaction by carboxylate. The second is a Fischer esterification reaction. And the third is a nucleophilic substitution of an acid halide. Next, I will show three different ways to make this ester. The first step is to use oxymercuration demercuration to hydrate the alkene into an alcohol. Next, we will convert the alcohol into an alkyl chloride. Then, we will use a Grignard reaction to create a carboxylic acid. Then, we will create an ester. We will then reduce the ester to an aldehyde. We will then use hydrazine to make hydrazone. Next, we will add KOH and heat to get rid of the nitrogen group. This is the summary of the reaction of esters. First, we'll use H0 plus with an ester to create a carboxylic acid. Next, we can do the same with NaOH heat and H3O plus. We can use excess RMGBr in water to create a tertiary alcohol. We can use DIBAH in water to create an aldehyde. We can use NH3 to create an amide. And then we can use excess LAH in water to create a primary alcohol. The first step in the mechanism for the acid-catalyzed amide hydrolysis reaction is a proton transfer. Next, it is the nucleophilic attack of water. Next, the base grabs the hydrogen to create another proton transfer. The lone pair on the nitrogen then grabs the hydrogen to create another proton transfer. Then the electrons on the oxygen atom create a double bond with the carbon to cause a loss of leaving group. Then the lone pairs on the nitrogen atom grab the hydrogen to create another proton transfer that will leave you with the final product. Next, we will look at the mechanism for the base-catalyzed amide hydrolysis reaction. The first step is to have the nucleophilic attack of the OH group. Next, the electrons on the oxygen group will create a double bond, causing a loss of leaving group. Then the lone pairs on the nitrogen atom will grab the hydrogen, causing a proton transfer. This will then lead us to the final product. Here we will go over the reactions of amides and nitriles. In the first reaction, SOCl2 will turn the amide into a nitrile. In the second reaction, LaH will be used to reduce the amide into an amine. In the third reaction, the nitrile will be transformed into a carboxylic acid using H2O plus and heat. In the fourth reaction, a Grignard reaction will be used to create a ketone. In the fifth reaction, LaH will be used to turn the nitrile into a primary amine. In the sixth reaction, SOCl2 will turn the amide into a nitrile. In the seventh reaction, a nitrile will be turned into a ketone using a Grignard reaction.